Good evening, everybody, and a very warm welcome to all the participants joining in today for day 4th of Women and Girls in Astronomy 2026. This event is being organized by Propagation Institute for Advanced Studies in collaboration with SS Citizen Science Group on behalf of International Astronomical Union in collaboration with Office for Astronomy Outreach. At Propagation, our mission is clear: to build world's largest and most impactful scientific community through structured space science education, through our space science school, winter school, summer school, and the rocket science programs that we learn. We are creating an ecosystem where students move beyond theory and real scientific engagement. If you're genuinely interested in pursuing space science in a structured and research-oriented way, you're welcome to register in our upcoming programs. Our collaborating partner, SS Citizen Science, is a recognized India's largest citizen science group and is actively promoting scientific participation. Now, coming to today's theme, from cosmos to climate action, connecting astronomy to environmental stewardship and urban astrophotography. Now, astronomy gives us a perspective. When we study planets, atmospheres, and cosmic systems, we begin to understand Earth in a deeper way, and that awareness naturally connects to environment responsibility and sustainable practices, even in how we observe and photograph the night sky. It is my privilege, an absolute privilege, to introduce our speakers. We have Ms. Sona Shukla, who's an amateur astrophotographer, an entrepreneur, a CEO. I just heard about her company, which is very, very interesting. Something that I really like. Passionate about. She's very passionate about urban sky observation, advocate for mindful and sustainable astrophotography. And we have another speaker, Ms. Kushi, who's a science communicator, an amateur astronomer, astronomy trainer, and starscapes experiences. She has an MSc in physics from Central University of Haryana. She is a citizen science with NASA and contributed to 195 supernova identifications and 49 preliminary asteroid discoveries. We are truly honored to have you both as our speakers today. We are very, very honored. With that, I formally invite Ms. Sona Sahani Gupta and Ms. Kushi Arora to take the session forward. The stage is yours, ma'am. Thank you.
So, welcome everybody, and sorry for the technical glitches. I think we all have been going through this since the pandemic. So, still something or the other goes wrong. So, welcome everybody, and a warm welcome to all the amateur astronomers and people who are studying astronomy and people who want to take up astrophotography. As I was introduced as an amateur astrophotographer, I have been doing astrophotography since 2020. This is my 6th planetary season, as they say. And I'm going to talk about the journey that I have been, the technical aspect of it, and how you yourself, from the light polluted urban skies, how you guys can also do at least take a look at the solar system, and you can image planets from wherever you are. Does not matter if you have a screen, you have an LED light right across your balcony. Even if it is hitting your telescope, doesn't matter. You can take images of our solar system giants like Jupiter, Mars, Saturn. When will be the results of the yesterday's quiz? So Syed, have some patience. I am sure the Propagation Institute will give you the results. Would you be interested in knowing about astrophotography, Syed? Or you're interested towards the quiz answers? Okay. Thank you. Thank you. So moving on, I live in New Delhi, and these are some of my best work so far. This was Mars in 2020. That's Jupiter, that's Saturn, that's Venus. Towards your right is the sun, and your left is our natural satellite moon. These are all images taken by me using my telescope and my planetary camera from my southeast balcony in New Delhi. Does it look real, or does it look AI generated? You guys can answer in the chat so that we can have an interactive session rather than me just Thank you, Roshni. Yes, these are real. It looks real. Thank you, Padma Lakshmi. Thank you. Yes, I'm going to talk about my telescope. I'm going to share how it looks like and the journey behind buying a telescope also. So I'm going to share everything. Yes, the moon looks very beautiful. This is a minute moon. I do not like, hi Raj, I do not like the gray moon. Somehow I feel that, when Earth is so colorful, why our satellite is portrayed only as a gray body? So I ensure that I bring out the mineral colors of the moon. So this is a bit about the photographs that I've taken through this journey, through this session. I'm going to share all the images, the progression, and you can see how better you guys can also start on this journey without having to spend a lot of money on this. Okay, so this is, I'm sorry, I'm going to take a minute or so on this picture because this is very close to my heart. This image was published in BBC Sky at Night magazine, and then it went on to be in the Sky at Night yearbook also. So if somebody has submitted their images to BBC Sky at Night magazine, they do, generally take your images, and if you're, the quality of the image is good, they definitely take it. But coming in the yearbook, that was something which was a surprise because that's where the editors select the image. You don't have a say in that. This is an image which was taken by me from my balcony, and this constitute about 53,000 frames. And this is a mosaic because I was using a planetary camera, so I had to take the moon in bits and pieces and then stitch it together. So that is why this image holds very dear to me. It was one of my initial captures, and it was I was successful in doing this, which was a great joy because normally in astrophotography, before producing even a single good image. So this is about the moon image. I'm going to talk about the basics of solar system photography. I'm not just going to stick to the planetary. You can do lunar as well. You can do solar as well. It's just that you have to use different techniques to image them. So the first step in imaging planets is a sequence we call lucky imaging. This is the technique which every planetary astrophotographer in the world uses for the simple reason, because if you're taking an image of a nebula is thousands and thousands of light years away from us, and you have to take long exposures to be able to see what lies in that area of the space. But since the solar system is fairly in comparison to all the other solar system bodies, the planets are closer to us. So if you take a still photograph, if you expose it long enough, even if you take a 30-second exposure, all you're going to get is a bright, shiny dot. You will not get the surface details. So in order to get surface details, we use a technique called lucky imaging. It is nothing but taking a video. Instead of taking a still shot, we use the video in our camera to take as many images as we can, so that once the video is taken by us, we stack it, and then we come with one single shot. So that is how planetary astrophotography is done. This is Venus, and you can see the atmospheric turbulence. The seeing Venus never actually reaches a good height and altitude where you can image it comfortably. So Venus is a very tricky planet to image. This was a video taken, then second image you saw was the stacked image. Now you're seeing the processed image, the sharpened image. So this is the technique we use to shoot planets. This is how, so somebody was asking about my telescope. So this is the telescope that I've been using. It is an 8-inch Skywatcher flex tube Dobsonian. This I use now, I have an EQ platform so that I can counter the Earth's rotation a bit. Like it gives me 2 minutes of, a time space where I can shoot the planets without them running out of my screen. So earlier when I started, this used to be my setup. This was my phone. You can see it is on video mode. I have this phone adapter, which is it is available on Amazon. It is very cheap, around 500 rupees. And this is how I used to do planetary. Initially, when I started way back in 2020. So everybody has a mobile phone. If you get hold of any telescope that you have, for serious astronomy, 8 inches recommended, 8-inch aperture is recommended, and Dobsonian being a Newtonian telescope, it is fairly cheap as compared to a refractor of that aperture. It is fairly cheap. It's a light bucket. It gathers a lot of photons. Now on your screen, you can see Jupiter moving. This is the actual video which I've taken from my mobile phone. The second part is Mars. You can see Mars. That was the first time ever I saw Mars. And the third one is, of course, the ring planet Saturn. This is how it looks on my mobile screen when I used to attach it to my telescope, the eyepiece and the telescope, using the adapter that I just showed you. Now, how do you do the imaging? Because Earth is rotating, the planets will move out of your screen. So there is a technique that I am self-taught. So I learned it all by myself. I use this technique called drift and align. So what will happen is that I will align the telescope. I will align the screen. I would see Jupiter somewhere here on my mobile screen, and I will keep it there. It will start drifting. So let's say it starts here. Can you see my arrow? Give me a yes. Can you see the arrow on the? Okay, wonderful. Thank you. Thank you, Roshni. Thank you. So this is where, let's say Jupiter will appear, and it will start drifting away this way, this way, this way, that, and it will get, go on, and I will lose it on my screen. So I will again align it, let it drift, and I will again align it so that it comes back again. I will start recording the video again. I experimented a lot with a lot of eyepieces from 12 mm to 4.5 mm to 6 mm to 25. But the best results I got were from 9 mm eyepieces. So I would request, if you guys have a telescope, if you have a 9 mm eyepiece, use that with your mobile camera. You will get some good images of our solar system planets. And there's another trick. When you switch on the video, you also get to zoom your screen, right? So I experimented again. You can get greedy. You can take it up to 5x, 10x. But what happens is that you are only collecting noise if you increase the zoom. So I would stick to 2x. So this is something which I have learned. I have done a lot of experiment. After that, I'm sharing this knowledge with you. When you're using your mobile phone on your eyepiece and telescope, the first method is to use drift and align. Let it drift from the screen, bring it back, start recording the video. Use a 9 mm eyepiece and then use a 2x zoom. Do not, get greedy and start using higher zoom. You can, but the results would not be favorable. So these are the images I was able to take when I was using my mobile as a camera on the telescope, 8-inch Skywatcher. This is partial solar eclipse, which I recorded from my balcony. This is how Saturn, so this is a stacked image. As I said, lucky imaging means taking videos. And then after taking videos, we process these videos in free software. And you can get images like this. You can see the rings clearly on Saturn. This is what Jupiter looks like through a mobile camera. This is the GRS, and there is probably a Ganymede shadow transit happening on Jupiter. Saturn again, Jupiter. This is Moon. Now, again, this is not a single image of Moon. I have taken a video and then I have stacked it. Because see, yes, you can take a single image of Moon, but there will not be, the depth in the picture would not be there. So if you are looking for some depth, if you're looking for some high definition, then lucky imaging is the only way to go when you're doing solar system photography. This is Saturn again, Jupiter. How many minimum ISO we need? So I think most of the mobile mobiles have their automatic setting. So you don't need to increase the... My screen is not visible. Okay, is it?
It
So,
is, ma'am.
so you don't need to do any change in settings. Just ensure that the video is on 4K and the maximum FPS it gives, because what you are doing is you are actually fighting the atmospheric turbulence, the seeing conditions. So in lucky imaging, we say we get few millisecond of time to get clarity in the atmosphere. When the atmosphere is absolutely stable, that's when we get one good frame of any planet that we are trying to image. So for mobile settings, I would go with whatever setting automatically are there in the mobile camera. Just use the video mode, do a 2x zoom, and you're all sorted. Now coming to the second stage, which I went through, everybody normally has a DSLR lying somewhere at home. So if you have a DSLR, all you need to do is you need to remove the lens. Here you have a lens. You need to remove the lens and use a T-ring. This is called a T-ring. So for example, I'm using a Nikon camera, DSLR. So I will buy a Nikon T-ring, which will, what will it do? It will help me to connect this to my telescope as a lens. So instead of a 200 lens or a 50 lens, now when I attach my DSLR, it becomes the focal length of the telescope becomes the focal length of my camera. So I get a 1200 lens when I'm using a DSLR with my telescope. This is how it looks like, you know, when you're setting up your DSLR to use and image planets. You see, this is called an imaging train in astrophotography lingo. This is an imaging train. At the back of it, you see the camera and you see an eyepiece extension. This is a tube because the cameras have a back focus. So the primary mirror is collecting the photons. It is then spreading the photons to the secondary mirror, and it is coming to your focuser. So the focuser and the camera's flange has to create a back focus so that the image can be projected onto the camera sensor. So I was able to get photographs through my DSLR by using this extension tube and an eyepiece also. Is on a basic water plan. Sorry. Okay, so everybody can see the setup. Now, I used to use 9 to 6.5 eyepiece so that I could get a little magnified picture of the planet, because the sensor on the DSLR cameras is a big sensor. So getting a tiny piece of space became a little difficult. So eyepiece was used to take images using DSLR camera. This is how Jupiter looked like through my DSLR. Again, DSLR used in a video mode, not in a still photography mode. This is Ganymede's shadow transit. This is how the early Mars looked like. And again, Jupiter, Saturn, Venus. Venus is a very, very bright planet. So in order to get good image, or not get a washout image, I would use a moon filter, which we normally get with every telescope. So I used a moon filter to get Venus, a little bit clarity on Venus. Now, after DSLR, I heard in my community that planetary cameras are the best. They are the way to move forward. Now, planetary cameras are basically a sensor and a heat sink and an aluminum body with USB 2, USB 3 connection. These sensors are designed by Sony, but these camera bodies can be made by n number of players like ZWO, QHY, Player One. So all of these companies make these camera. The sensors remain universal. These are Sony cameras, Sony sensors, I'm sorry. And their main focuses to get highest FPS. So in order to beat the seeing conditions, the atmospheric conditions, we need the highest form of frame per second. So these cameras specialize, they're made for planetary imaging. So these are specialized camera, and they help us to get the maximum frame per second. Now these cameras look, they are specially made, so they'll be expensive, but on the contrary, they are cheaper than a mobile phone. They are cheaper than a DSLR. From an entry-level camera like 178 MC that I still use, it could be around 20,000 to 30,000. You can easily get a planetary camera. Now, this is how my setup looked like when I started using my planetary camera. So you can see this is my flex tube Dobsonian, and this is the camera attached. There is no back focus issue. The flange of these planetary camera is 17.5. So the back focus is pretty easy to manage. I use a Teleview PowerMate 2.5x. So my total focal length becomes 3000 mm when I'm shooting shooting planets. And this is the USB 3 cable, which goes to my laptop. Now my screen is not at the back of it, like it was there when I was using mobile camera. I was using the DSLR. I could see the planetary body. But with this, I had to use my laptop in order to get the lucky imaging or the videos that I shoot from. Any questions so far? No? Now, this is very tricky because it looks very easy, and the images that you have seen in the beginning, the first slide, you would think that it is very easy, but it was one of the toughest things that I ever have undertaken. And my love for this hobby exponentially grew because it is very, very challenging. It's not easy to get Saturn or even Jupiter on the laptop screen. So what you have to do is, I used to do manual tracking when I initially started, because you can see this is a manual Dobsonian. It cannot align, it cannot counter Earth's rotation. So I had to use the drift method again, and then pause the video, again realign. So the best friend that you have in all of this is your finder scope. So yes, I use SharpCap. I do not use Nina. Nina is not for planetary photography, I believe. Nina is exclusively for the DSO setups. I use SharpCap. There is another capturing software called Fire Capture. So these are the two of them. Both are very, very good, but I am very acquainted with SharpCap. So I use SharpCap as the primary acquisition software. You need to align your finder scope precisely. Then you have to make a note that, in all of the finder scopes, there is a cross, which appears in the front of the lens. So you have to ensure that you take a mental note where you have seen the planet emerge in your finder scope and where it is exiting from. And then insert a 25 mm eyepiece so that it gives you a big FOV. After inserting the 25 mm eyepiece, you need to insert your Barlow or PowerMate, whichever you're using, so that the focal plane will change. Once you introduce another element of lens in your imaging train, the focal plane will change. So in order to understand from where it has shifted, the focus has changed, you need to use the 25 mm eyepiece along with the Barlow or the PowerMate. Once you can see the object right in the middle of your eyepiece, take out the eyepiece, insert 6.5 mm eyepiece, because the sensor that now you're using with a planetary camera is a very, very small sensor. So you will be deeply disappointed. It took me a week to figure out why I cannot see Jupiter or Saturn on my laptop screen, because the sensor of these planetary cameras is very, very small. So it was very difficult. And then the method that I'm sharing with you today is because I've experienced it. I have experimented a lot, and now I can, with some authority, I can share with you that this is the way you can do manual tracking, and you can use a planetary camera to get images of any planet, any solar system body that you wish to image. This is what my home screen looks like. This is one of the best Saturn I've ever taken. I'm yet to beat my own image. This is very, very clear. You can see the C ring also. And the Cassini division is very, very clearly visible, along with the hexagon and along with the numerous very clear belts visible on Saturn. The above three planetary processing softwares that I use, these are absolutely free of cost. And PIP is used because I do manual tracking. So I have to center my object, then the auto stacker can stack it, and Registax is used for sharpening. So this is not going to be covered in today's session. It's a session in itself. So this is what Jupiter looks like through a planetary camera. This is one of the live video recordings that I have with me. This is the screen of SharpCap, the acquisition software that I use. You can see Jupiter is along with one of its Jovian moons. I think it is Ganymede. On the right, you can see the screen, the settings that I use for SharpCap. And this is how actually it looks like on my screen. You can see the frame rate in the down bottom tab. It is 151. This is the maximum FPS that I have been getting from my camera, which is ZWO 178 MC. It's a one-shot color camera that I use. Now, this is Mars at its best. It was 2020. Its apparent size was 20 arcsecond. It looked beautiful. You can see the blue. These are not artifacts. You can see the polar ice cap. These bluish tints that you see are not the artifacts. I know for sure because I checked with the other very, very senior and professional planetary astrophotographers like Damien Peach, Christopher Go. Their images also had this bluish tint, which was the carbon dioxide clouds emerging from the northern pole of Mars. So this is the difference between shooting through a mobile camera and shooting through a DSLR, and then using a specialized camera for imaging planets. I'm going to show you a lot of Mars because Mars was magical in 2020. It is going to be magical again in 2035, but 2020 was very special, and it was my first time imaging Mars, and I could extract so many details using the setup that you just saw, the telescope, the manual telescope. So this was very special for me. I have captured Olympus Mons a lot of time. Olympus Mons, I'm sure you guys would know, is the biggest volcano in our solar system, which is present on Mars. And yes, a lot of bluish clouds I could see through my eyepiece also, not only on the camera. Here you can see Olympus Mons, very, very defined. And these are the carbon dioxide clouds which were spreading all across Mars that time. And in fact, at the closing of the 2020 Mars season, I was able to capture the dust storm on Mars also, which is uploaded on my YouTube channel. You can clearly see the dust storm emerging in Mars. Mars again. Mars with Olympus Mons, the blue clouds. This was one of the breathtaking moments of my planetary imaging. This is Saturn. If you clearly see, there is one of the Saturn's moon is casting a shadow on Saturn. I was able to capture it from Delhi, from light polluted city. So all in all, guys, I was just going to show you a few more pictures of mine. And all of these images that I've shared with you are available on my social media handles. You can see all of them there. A lot of technical details I share along with my images, like what was the frame rate, how many are stacked. So all of that is visible in all of my social media posts. I think you guys would receive my email. It is sent as a Google Drive link because the PPT is a little heavier. So any questions so far, guys? I would be happy to take your questions, and then we can wrap up the session. Ma'am, could you recommend a telescope? Yes, I use a Newtonian, which is a Dobsonian setup. I would recommend to buy a Dobsonian, and these days, a lot of secondhand telescopes are also available, so you don't have to spend a lot of money. And there is nothing wrong with the secondhand telescopes if you just have to check the mirrors, the optics of it, and you will get it at half rate. So buying a Dobsonian and 8-inch is recommended to do some serious astrophotography. Otherwise, you will not get as clear details as you would desire to get. How did you manage to avoid the light pollution? So I don't know if you closely observed the screen that I shared, where you could see the balcony and you can see the setup. You could see a red color bed sheet hung on my balcony. So that was to avoid the street light right across my balcony. So few of the things you can do to avoid light pollution, but as I said, solar system imaging is fairly doable when it comes to light pollution. It does not affect your images that much. You can click Jupiter right along with moon, and you will still get a good detailed image of Jupiter. So light pollution is not an issue when it comes to planetary imaging. Any other? Thank you, ma'am. You liked my image. You can check my handle, Astro by Sona. You would. What is opinion on smart telescopes? I have recently purchased Masoom Jetwa. I'm all for technology. That's wonderful. But I'm a little old school also. So if you don't enjoy the night sky, if you just want to sit on your mobile screen and let the smart telescope do the work, then of course, smart telescopes are very good. But as I've demonstrated, you can use the traditional method of astrophotography and get good images. So either ways, whatever works for you is good. Origin and C star. Okay. But I want to have an opinion. So opinion, you should experiment yourself. Come on, you guys are science students or science graduates. You are in the science stream. The motive is to experiment as much as possible. Ma'am, do you take classes in Delhi of astrophotography? No, Manishka, I don't. This is, as I said, my hobby. I have a full-time company to run. But you guys are more than welcome to ask me questions, DM me. I can guide you, I can answer. That's not a problem. The original color of sun is white, correct? Absolutely. Then why does it appear yellow in color, ma'am? So you can find out. You guys are science students. You know the answer for this. I know the answer for this, but you guys also know the answer of this. Okay, ma'am, thank you. It is really incredible session. Too funny. This is your first day. Okay, so first day you're learning a skill. I'm very happy. I would be happy if you guys start clicking the moon. The full moon is coming. So if you have a community where you can use somebody's telescope, please take your mobile phones and start clicking videos of moon and see what kind of results you get. Ma'am, any upcoming workshop at Astro Manesar facility? I think it was happening yesterday, 28th. There was a workshop, planetary parade going on there. But keep a tab on Ajay sir's homepage. You will find out about all his workshops. Is there any celestial body or maybe constellation that you like to see, like personal favorite? There are so many. I am in love with the cosmos. There's just too many. I mean, like there's this Casper Nebula in 78 in Orion region right now. There is IC 1805, that is the Heart Nebula in Cassiopeia. There's just so many. What are some good apps? Good apps? Which apps? Stargazing apps? Sky Safari? How does atmospheric turbulence affect image clarity? Oh, I have shown you a live example. I've shown you the live image of Venus, how it was shimmering, how you could not even see it stably. So that is what atmospheric turbulence does to your image. What are some good apps or books you will recommend for a 12-year-old who wants to learn more about the night sky? The best way is to go to the planetariums near you. You will sit inside the dome. You will see the practical side of the sky, and buy a binoculars instead of any app or something. Buy a binoculars and start stargazing. Whether you're 12 or whether you're 10-year-old doesn't matter. You can start at any age. While clicking the moon, it is not very clear. I'm sorry, the messages are just running away from me. I use Stellarium for detecting planets' position. Yes, that's a very good, very reliable app. I'm not really sure, but while introducing it has been said that you would take in many supernova images. No, that was not me. I think that was the next presenter who has 190 something supernova discoveries. So I don't think people image supernovas. That is only very sophisticated telescopes in the world who are doing that. But I think the next presenter has, to her credit, the discovery of supernovas. That was not me. I am sorry, you misunderstood. Did I miss any questions? I think I have. While clicking the moon, it is not very clear as well how to avoid light pollution. I have said it again and again, there's no need to avoid light pollution if you're doing solar system imaging. So don't worry about light pollution. Only when you're taking long exposures in deep space objects, then you start worrying about light pollution and gradient in your images. But when you're doing solar system, don't worry about anything. The signal to noise ratio improves as you take thousands and thousands of frames. All right, so I think my time is up, and I'm sorry for the last glitch. Jitu would have received my presentation now, which is too late. It was just some images. And thank you so much, guys, for being very active throughout the presentation and asking me interesting questions. You can DM me on any of the social media platforms. I'll be happy to guide you, happy to take you through the journey of the cosmos in my amateurish way. I'm not an expert, but I love astrophotography. So all the best, and keep looking up. Thank you, guys.
Thank you so much, ma'am.
Thank you, ma'am. It was really nice session, ma'am. Please give me all of your social handles and where you have been putting all of your images. I'll just provide them so everyone could.
Yeah, it's universal. It's Astro by Sona everywhere, in Facebook or in Instagram. I'm on Reddit, but I'm not on Twitter and not any other social media. It's very exhausting to be on social media. So Astro by Sona, you can see on Instagram. That's the best place. I love using Instagram. I'm usually there.
Okay.
All right. Thank you, guys. All the best. Enjoy the next session. Hi, Kushi. I've heard so much about you. Welcome. And hope to see you sometime, actually, in a star party.
I would request Kushi ma'am to please turn on the camera so we could just continue the second part of it. Everyone, just you don't need to leave the session. Okay, it's still there only because we are having the two speakers today. The one is done till now, and the very interesting one is still left. So yeah, you do not need to leave this.
So I request everyone, if you want to have any questions, so you can drop it in the chat box. I'll be happy to answer all of them side by side. Along with that, if I ask a question, whether you know or don't, please don't be shy, because you all are science students. And there is an interesting fact about science students, is that we are adaptable to all the things. Whether it's comments, whether it's beliefs, whether it's about knowledge. Okay, so please allow me to share my screen.
Yeah, ma'am, you can do that.
Okay, thank you very much.
Before you start, ma'am, let me just tell you, lots of people do not know lots of things about you. So I would like to say that please introduce yourself, ma'am.
Okay.
Get to know more about you. Yeah.
That's a great thing to introduce myself. Okay, so let me start from the very start. I am a science enthusiast, just like you all. Okay, from the very beginning, let me tell you the exact year that was 2020. So I was at home enjoying the COVID time, and at the same time, I was exploring myself. At the same time, I was, um, working to enhance my astronomical skills. So that time I start working with some of the companies. For example, I started with the Society for Space Education Research and Development, that is known as SSCRD. And then the company has changed its name from SSCRD to Genic Space, so you can search that. From that time to advancing my knowledge, as well as participating in some citizen science programs to discover some asteroids and supernovas. So that was me you were talking about, who were the discoverer of those, like so many supernovas. I was the one. I am proudly say that. So that was the thing. So that's how my journey starts. I love exploring space. I start clicking some photographs from like my having a small telescope to like big ones, and then like working a lot of times with a lot of companies. I just worked on my skills. Okay, so right now I am doing my master's in astrophysics, and at the same time I am the astronomy educator of Starscapes experiences. I'm sorry, I was like blundered. Okay, so I work with Navar's education as well. So right now I am the Starscapes person. Okay, so let me take you to my particular slide and tell you like what exactly the Starscapes is. Okay, let me take you to this. Give me a minute. Okay, so there is a question from okay, can you see my screen? I don't know like what
Yeah.
exactly.
Oh yeah, ma'am, it's visible. You are sharing completely. Yeah.
Okay, now is it visible?
Yeah, ma'am, it's visible.
Perfect.
Close this tab, ma'am, because it is also coming up. So
Yeah. So who was the person to ask me something? Okay. So is it only astrophysics or astrophysics and cosmology? So by the way, let me tell you, it is both in astronomy and cosmology, because I'm doing my master's in physics. So it accomplished both of the subjects. If in a case my department is not providing any course, so I'm looking for something, and at this or like I used to Google it, get some courses from other universities as well to get my knowledge. So yeah. And another question from Manishka Dubey. Ma'am, I did one course from SSCRD when I was 7-year basics of satellite. That's great. I was in the back end of that particular program. I was the one who was providing content to the educators who were there in the front end. Okay. So today I will be talking about a lot of things, okay, to make you comfortable with what the things are going on the environmental part as well as astronomy, because that's important to understand in the perspective of the nature as well. We all used to see the stars, and to see the stars, I let me take you to this particular slide of starscape experiences, because you should know what exactly it is where I'm working right now. So starscapes is
ma'am,
basically,
excuse me,
yeah.
ma'am. Actually, sorry, ma'am, but your screen is like that above one, ma'am. The chat one. It's visible a lot. Like that's why the
Oh,
perfectly is
okay.
not
Okay,
visible.
I
Just
got
close
it.
this tab, ma'am.
There is
What we actually do usually, ma'am, like first, just give your session first. Then we just allow everyone to ask the every
okay.
questions. Okay, like
That,
in interactive parts. This
yeah, that's
in the
in
chat, lots of people is not being able to interact.
okay.
So,
Okay,
this is
okay,
important.
yeah.
Yes.
Okay, let me take you this particular slide. Thank you so much for like guiding me. Yeah? That's important. Okay. So Starscape Experience is basically it's a series of immersive astrotourism and stargazing activities that offered across you could say, let me take you to this particular slide. Okay. So
Just
it's very
close this, ma'am.
disturbing. It's at the
Just
same time I'm very
close it,
confused.
ma'am.
Okay.
Yeah.
Okay.
This will be fine. Yes.
Okay, perfect. Now, That's great. So at Starscapes, you can expect a mix of astronomy, science education, and hands-on experiences that's suited for both beginners, enthusiasts, family students as well. So at Starscapes, we used to provide guided stargazing sessions to explore constellations, star clusters, galaxies, planets, etc. Through we have powerful telescopes. So expert guides, they explain what you see, like how to identify objects and the science behind them. So then other thing that we offer is solar observations. We have moon and planetary view. We have astrophotography workshops. So if you're interested, you can DM me. I'll give you my number as well as my contact details on both social media as well in the last of the session, so that you can contact me regarding the starscapes if you want to join us in a way like you want to learn something. Okay, so let me take you to those particular slides which are very important right now. That is why we connect cosmos to the climate. Okay, so like starting from the start, we are discussing astronomy from last time, that is from past few sessions. So what is astronomy? So astronomy is basically the scientific study of celestial objects and cosmic phenomena. So when we say celestial objects, we mean everything that's beyond the atmosphere, that is stars, planets, moon, galaxies, etc. But astronomy is not about objects, right? So it's about process. So how the stars are born, how galaxies evolve, how gravity shape the structures, and how the energy travel across the space. So that is all about astronomy. So we have a lot of things. You might wonder, like, how does studying a black hole might millions of light years away from us to understand our climate. So we're gonna get here, but first understand astronomy teaches us how the system behaves under the fundamental physical laws, that is the gravity, thermodynamics, we have radiation, magnetism, and the earth operates under the very same laws. So it's both observational and theoretical. You have attended the Sona ma'am's session. That's totally observational, because you are observing these things with the help of a telescopes, right? So we observe using telescopes across electromagnetic spectrum, okay, from radio waves to visible and to X-rays. Okay, let me take you to this particular thing, that is what is electromagnetic spectrum. So electromagnetic spectrum is basically, we have a scale, okay, and it is both in wavelength and frequency, in the terms of wavelength and frequency. And when we like make a graph like this, we have radio waves, we have ultraviolet rays, we have gamma rays, X-rays, all in a way of increasing or decreasing wavelength or frequency. That is called as electromagnetic radiation. Okay, so we built planetary atmospheres. So that's how we to study, basically. Okay, so astronomy relies on telescopes, satellites, and space mirrors. And here the bridge begins. Many of the technologies originally developed to observe the distant stars. They are to monitor the Earth's atmosphere as well. So satellites that measure infrared radiation from the galaxies, they also measure the heat trapped in our atmosphere. So we have some space-based instruments to detect the cosmic dust, and also to track the aerosols and pollutants that are present in our climate. So astronomy is not just to looking outward, it has given us the tool to look back ourselves. That is like how the things that we are doing on Earth. And when we look at the Earth from the space, so we begin to understand how fragile it truly is. Okay. So the question arises is why we connect the cosmos and the climate. So at first glance, astronomy and climate sciences seem belongs to completely different worlds. One looks outwards towards the galaxies, billions of light years away. The other look inwards at forests, oceans, atmospheric sciences, systems on the Earth. Okay, so environmental sciences, they focus on Earth system, right? The atmosphere, hydrosphere, we have biosphere, we have cryosphere, there are a lot of things. So it examines how the energy flows through the climate system, right? How the radiation from the sun that interacts with the gases that is present on the Earth, and how the feedback loops that amplifies and it regulates the temperature, basically. So you notice something? there are also physics-based systems, right? So Earth is not isolated, it's a planet that is orbiting the star, and that star is the sun. Okay, so our climate is driven primarily by the solar radiation. So our system totally depends on its axial tilt. That means the Earth has its axial tilt of 23.5 degree, right? So long-term climate variations, they all are influenced by these orbital cycles. So let me take you to this a very simple line. The Earth's climate is basically shaped by astronomical factors. Simple. So you can't fully understand Earth without understanding in place of the cosmos. So that's how we connect these two things, and like the very tools that are developed for astronomy helps us to monitor the climate change, right? So satellites measures atmospheric temperature, they detect greenhouse gases, they observe melting ice caps, and also they track the deforestation. So all of this is possible just because of the space science that is we having. Okay, let me take you to this. So this slide is like over. Like I was just talking about this in the previous slide. Okay, so there is a question. What is environmental stewardship? That is in my title. That's a very fancy title, and you are confused. Like what exactly it is? So this is all about how like we protect the things. So environmental stewardship is basically responsible. Uh, is the responsible use or and protection of the natural environment, I would like to say. So it means we recognize the natural resources that are not infinite. So it means understanding that we are not the owners of the earth, we are temporary caretakers, and the stewardship implies a responsibility across the generations. And like what we today do, it affects the people they will never meet. Okay, so that is you could say a sustainable development. Okay, sustainable development means like meeting the needs of the present without compromising the ability of future generations to meet them. So it's not anti-development, it is the intelligent development, development that respects the ecological limits. Okay, so there we have the third point that is like written in my slide, is that's the conservation of the sources. So conservation is all about balance, water, forest, soil, biology. These are not just environmental assets, they all are life support systems. So if earth was a if earth were a spacecraft, you can imagine that, in many ways it is. So these systems would be our oxygen supply, our temperature control, and recycling mechanism, you would like to say. So there we need to take this climate action in the stewardship in the motion. So it is where the science meets the policy, where awareness means implementation. So but its core, stewardship is also ethical. That's very confusing to you guys. I can feel, I can see your faces, but I can feel so many of you are confused. So let me take this particular slide. Okay. The thing is that Earth is very unique planet. Okay. First, it has a liquid water. Of course, water is essential for life as we know it. Stable environment, magnetic field that is that's exactly works as a shield, from the solar wind and the cosmic radiation. That's the magnetic field, and without it our atmosphere could slowly erode, as it likely as it has likely happened on the Mars, if we give you the example. Okay, so then we have some plate tectonics, a perfect distance from the sun. Okay, so um, I would like to say ki if earth was in not in this particular place, so this would be next to impossible to have a habitable zone on the earth. And that's here the concept of the habitable zone. That's a beautiful example of how astronomy and the climate intersects. So this we use as a concept to search for life for the exoplanets, but it also reminds us to how finely balanced our own planet is. Okay, so let me take you to this particular slide where I am showing you the sky brightness comparison. Okay, the inner sky to the excellent dark sky reserve. I have some images, and I would like you to see this image very carefully. So on the left, we have inner city sky, and on the right, we have an excellent dark sky site. Okay. So this scale represents how much artificial light intervenes with our view of the universe. So in heavily urbanized areas, we may see only a few dozens of the stars, and in truly dark sky locations, we could see a thousands of them. So in the upcoming slides, I would generally focus on how the adaptation of the night sky is important for not for us, but also for some animals and the species that are adapted to it. Okay, so that's all in the upcoming slides. So let me give you a brief of that. Okay, for nearly one third of the humanity, the Milky Way is no longer visible. So entire generation are growing up without ever seeing the galaxy in the night sky. That we live in basically. Okay, so it's not just an astronomical loss, but it's also a cultural loss, it's also a psychological loss, and it's also an environmental loss. So light pollution, it is not harmless. This is a very wrong statement. If you say this to a person who is not in astronomy or something like this, so you will like to say, okay, light pollution hai, theek hai, it's all right, hota hai, sabke ghar mein light jalti hai. So basically, it wastes the energy. It also increases the carbon emissions, right? And it also disrupts the ecosystem. So let me take you to this particular site. We all are exposed to these lights, these street lights in the night. Okay, at some places it's important. I would like to say, yeah, that's important. But at the same time, it wastes energy, it increases the carbon emission, and it also disrupts the ecosystem. So these artificial lightings, they affect the migratory birds, sea turtles. We have some insects that are prone to these particular lights, and we have some human circadian rhythms, right? So we began as technological progress that quietly become an ecological imbalance. That's very sad for all of us. So that's what the human have done. So this image like looks very normal to us, right? A well lit highway, modern infrastructure, everywhere it is. But are we lightning what need it to be lit, or just be lightening the sky? I would like to say. So poorly designed lightning, they send a significant portion of the light upwards. That's exactly the what we call as light pollution. So that upward light, it scatters in the atmosphere, and that creates a sky glow. Okay, and every wasted photons, that means a small packet of light, you could say energy. Okay, it represents the wasted electricity, right? And in many regions of the world, electricity still means fossil fuels. Today we have solar panels and other ways, windmills, to generate the electricity. But at the same time, there are a lot of places which uses the fossil fuel to generate electricity. So light pollution is indirectly linked to carbon emissions, right? So environmental stewardship is not about turning all of the lights. It's about smarter lighting. It doesn't mean ki aap log jao aur sari battiyan band kar do. It's not like this. Okay, so we have some shielded, we need to have some shielded fixtures. We need to have some warmer colored temperatures, motion sensors, you would like to say. I would like to say some energy efficient LEDs that use responsibility. This is where the astronomy meets the policy and the design, right? Okay, let me take it this particular slide. Okay, I would like to say request everyone, if anyone wants to comment on this particular image, what exactly it is. Can you tell me? Anyone voluntarily? It's open for you. Am I audible? Hello? Okay, I'm confused. If okay, let me take this particular slide. Hello? Okay, I was very confused. That's why I stopped sharing my screen. Okay. Uh, yeah, I got some night comments. Yeah, that's great. This is a night sky map of like maybe taken from a flight or takeoff. Exactly, it is. Okay, from a city above. Okay, let me take you to this. Slide again. Okay, that's very confusing for all of us. Okay, let me just share this entire screen because that's confusing for me. That's why I put less content so that you won't confuse. Okay. Let me just drop it very small. Okay. Okay. Now, is it possible for you to read all the things and see my slide perfectly? Yeah, I think you all can. Okay. So this is the Earth at night that is seen from the space. It's breathtaking. Yeah, it's a beautiful picture. How human civilization glowing across continents. But if you look carefully, what we see here is energy consumption, right? Every cluster of the light represents infrastructure development, but also the resource use, right? From one perspective, the image represents progress. From the another, it represents inequality and the environmental strain. So some regions shine intensely, whether other remains dark, and that raises a direct question about sustainability and equitable development, right? So if another civilization were observing the earth, they would detect artificial light that we are providing, right? So they would see industrial gases, they would measure atmospheric changes. So what a story that, like, I would like to say ki, what story would our planet be talking, right? कि बड़ा अजीब सिस्टम है ये लोग अजीब सिस्टम है. So when we talk about what happens during dark adaptation, because I was talking a lot about dark adaptation, dark sky reserves, and all of the things. So, um, for example, if we turn all the lights off in this room right now, what would you see? First thing, you would see nothing, right? But after a few minutes, shade would begin to appear. Okay, so I will not going to speak in Hindi. I'm like totally speaking in English. Some of the people one might understand Hindi. Okay, so but after a few minutes, the shade would begin to appear. So after about 20 to 30 minutes, your eye would reach peak sensitivity, and that is we call as the dark adaptations. So I am giving you this particular thing, that is the human eye structure. You would see. So in low light, our pupils, they dilate, that means they expand, and this allows more light to enter our eye. This is the body's immediate response to the darkness. So, but at the same time, dilation is not enough. Okay, let me take you this thing. Here it is. Good. Okay. But the dilation alone is not enough. So in your retina, you have two types of photoreceptor cells, that is rods and cones. So in darkness, the rod cells become dominant, and in the brightness, the cones will going to be dominate. So rods, they are made extremely sensitive to faint lights, and that's how they allow us to see the stars. So there is also a photopigment that is called as rhodopsin. So in bright light, the rhodopsin breakdowns, and in the darkness, it regenerates. And that regeneration increases our sensitivity to dim light dramatically, and that's why even a quick glance at your phone can ruin your night vision. That's a tip from my side. Okay. So after full adaptation, the human eye becomes nearly about 10,000 times more sensitive than a daylight. So that means the night sky is not empty; it's our lightning environment that makes us you could say invisible. So when artificial light floods our surroundings, so we are not just hiding the stars; we are biologically interrupting our natural vision system. So this affects wildlife as well. So many species, they depend on darkness for navigation, hunting, reproduction, and that's how the picture comes in. The light pollution is not just an astronomical issue; it's an ecological one. To understand this more clearly, let's briefly look at how the things are. Okay, so let me just zoom this picture if it is possible. Okay, yeah. So we have these two types of cells. Okay, let me just give you again a brief. That's important because some of you might confused if I'm learning astronomy or biology, like what I'm doing right now. But it's important. because we are discussing astronomy, and this is a very crucial part of astronomy. Okay, so this is the anatomy of the human eyes. The light enters through the pupil and it focuses on the lens that is behind the pupil, and that light, after adjusting from the lens, it falls on the retina. So retina is where the light becomes electrical signals, and that signals, they are transferred to the brain, and that's how the things work. So we have the cones. That cone cells work in bright light. That allows us to see the colors and the fine details. So they are concentrated in central part of the retina, okay? But they are not very sensitive to the dim light. At the same time, we have rods that are very incredible. You could say they're incredibly sensitive. They detect the faint light. They do not see the color, but they allows us to see the darkness. So that's why the night sky appear mostly in the shades of the gray. That's how the things work. In our biology evolved under dark sky for thousands of the years. Humanity lived beneath natural darkness. So today, excessive artificial light, that disrupts not just astronomy, but also the human sleep cycle, hormonal regulation, and ecosystem balance. That's how you connect these things. Okay. Okay, let me take you to this slide. That's important. That's important. Yeah. Okay, we have some spaces, and they are need to be discussed. When we speak about dark skies, we often think about astronomy, but darkness is not just for astronomers. It's a biological necessity, right? So we have some species called as nocturnal species. These are the animals that have evolved to live and thrive in darkness. For let me just zoom this thing. That's confusing. Okay. So for millions of years, Earth followed a simple rhythm, that's day and night, right? And the evolution responded to that rhythm. Okay, perfect. So certain animals adapted specifically for low light environment. So many species, these animals, they have high sensitive rod dominated vision, right? Recall those rods, they are dominated in the night, and these animals, they can detect faint light far better than humans. For example, owls, we have some foxes, hedge horses. So their eyes are designed for darkness. So when artificial light floods their habitat, it overwhelms their sensory systems. So predators such as owls and bats, chamkadar, they rely on darkness to hunt effectively. So artificial light, they can these can expose them or confuse their prey. So some prey species freeze under sudden illumination. So this changes predatory dynamics. And for some smaller animals, darkness is also a protection. For camouflage, this is a kind of species. So excessive lightning removes that protection. So increases its vulnerability. So some species, they also navigate under celestial clues. So birds use stars for migration. We have Google Maps, we have maps, we have people who are like far more intelligent when we talk about roads and things, navigation. But birds, they totally rely on the stars. Some insects, they aligns with the moonlight. So when artificial light mimics or overpowers the nature, that the light sources, so it becomes disoriented, it becomes hard. Migration routes, they shift, and fatal collision increases. So there are also certain species, these animals, they can communicate visually or acoustically. That means through the medium of sound in dark environments. So light intrusion after alters these behaviors. I would like to say, yeah, alters these behaviors. And when this behavior changes, the ecosystem totally going to change. So artificial light is relatively a new phenomena in evolutionary history. So ecosystem evolved over billions of years under predictable cycles, right? So it's over a century when we have dramatically altered the night. And this phase of change is not something evolution that can keep us with. Okay, one more confusing thing. I'm thinking, like, you might get it. How does the celestial navigation things comes in when we talk about birds, right? So you all know about Orion. right? Orion is a constellation in the night sky. Right now, you can see in the night sky, it's there. Okay, three stars in a belt. This is the way of detection. Some of the circumpolar constellations are also there. That is the Ursa Major, Ursa Minor. All right. So these are the constellations that helps us to navigate. Okay, in which location we are right now. We have our pole star. Pole star aligns in the north direction, and when we look at the pole star, okay, we are in the direction of the north. So in the same way, like there are some species. For example, we have some birds. Many migratory birds use these constellations to navigate during long distance flight. Okay, I'm not going to talk about these particular two constellations. There are a lot of constellation, almost 88 constellation in the complete celestial sphere. Some are visible in the northern part, some are visible in the southern part of the earth, and these migratory birds have their own mindset. Okay, they don't rely on our particular constellation. They have their own picture of constellations. Okay, so they travel thousands of kilometers, often at the night. So some experiments have happened, and they have shown that the birds raised in planetariums, they adjust their orientation based on the projected star patterns. Uh, Let me take you to one such example. I recall this example right now, that is indigo bunting. Yeah. So when the star pattern is rotated, the bird changes the direction accordingly, and it tells us something that is very profound. That these are they are not following a single star. They are reading the rotational pattern of the night sky. So when the artificial sky glow washes are the stars, so we are removing the celestial maps of these birds that they are depend on. Okay, so this increases the disorientation and collision with the buildings as well. So another example I am giving you is the dung beetles. Here you could see the name is written. It's very ajib name. So perhaps even more fascinating, that's dung beetles. So researchers have shown that there are certain species that navigate using the Milky Way. So they climb on the dung ball and they orient themselves like using the bright band of the galaxy that we can see in the night sky. And they roll in the straight line away from the competition. So yeah, insect use our galaxy to navigate themselves. So when the artificial light is there, it obscures the Milky Way, so their natural compass, it totally disappears. And the third species that's most prominent is sea turtles. So sea turtles hatchings provide another powerful example. After emerging from nests to beaches, these instinctively more towards the brightest horizon for millions of years. So brightness comes from the moonlight. They reflect in the ocean. But today, artificial coastal lightings offer. I'm sorry. They often becomes the brightest source. So these particular types of insects, they move towards the sea, and many they don't survive. That's how the biological uh, things, they like compatible along with the night sky observation. Give me a minute, let me drink some water. Yeah. Okay, is it like, am I visible?
Yes, ma'am.
Yeah, great. Okay. So sometimes I need water because I'm talking so much. I can talk for English. That's how the things is. Um, Let me take you to another slide that's also important. Um, we have learned about birds, we have learned about insects, we have learned some species, and at the same time, uh, we should learn about extreme darkness where is no sunlight. It's also important when you talk about astronomy. It's very fascinating. That's why I have added these things. In deep sky beyond around 10,000 meters, sunlight don't reach, and that's the perpetual light for millions of years. Life has evolved in complete darkness. That's not temporary light, but absolute darkness. And here the another feature that comes in, that's bioluminescence. And in response, many deep sea organisms, they evolved bioluminescence. They produce their own light through chemical reaction, and that's not electricity, it's biology. That's the living light. anglerfish is an example of this particular things, because some deep sea species, they develop extremely large eyes to capture the faintest light, so other lose light entirely because sight becomes unnecessarily, and that's how the evolution takes place. They optimize the energy use. If light is absent permanently, the body adapts. So that's a powerful thing. From deep oceans to open sky, darkness is not emptiness, it's a habitat, it's an information, it's an evolutionary infrastructure. So I want you to consider this. If life can evolve to produce its own light in total darkness, should not we able to capable of designing our cities to respect the natural darkness? you know Limiting these particular sites. And here the thing is key, like why it is important. Because first thing is key, these particularly thing that artificial light comes in and it disrupts not us but a lot of things. The disorientation of the birds. Many millions of migratory birds travel at nights, I've told you right now. So they use stars and geomagnetic clues and horizons glow for navigation. So, but bright city lights disorient them, and they circle illuminated buildings. You can see around you. The Sometimes in the late nights, you could see some birds. They are circling around some brighted or illuminated buildings. And these collision, they increases dramatically during the migration season. It's not rare; it happens globally, everywhere, in India, in foreign, everywhere where the light pollution is there. Another is that we have some sea turtles, as we discussed earlier, hatchings instinctively move toward the brightest horizon. And in natural condition, this is the ocean, but coastal lightings, they alter the gradients. And along with that, some insects are there, altered predators are there, and a lot of things. To fully understand this impact, we must zoom out, because our light pollution is not isolated. It's a part of the also interconnected things. That's atmosphere, biosphere. Well, let me give you a brief about it. Atmosphere regulates the temperature and climate. Okay, it interacts with the radiation, including the artificial light, and that light scatters in the atmosphere that creates the sky glow. And this shows that light pollution in the atmosphere is having some interaction. And then we have some a part of the uh, you could say earth called as biosphere. It includes where the living organisms present. When we alter light cycles, we alter biological process. And then we have hydrosphere, as we told about. Coastal lighting, it affects marine species as well. So urban runoff and energy production also link the light use to water systems as well. So that's how we need to think. Astronomy teaches us to think in the system, right? Climate action requires some system, you could say, thinking. And our environment stewardship is something that demands what we see the invisible. Okay, let me stop sharing and let's have some discussions. Okay, and that's where my favorite part comes in. I don't like to have a lot of things with the PPTs. Okay. Okay. So let me take the questions from the chat box. Okay. You have some doubts, you can post it in the chat box. I am giving you the answers. Okay. We have a question from Masoom Jetwa. Is light pollution treated as an environmental tragedy or just an side of it? Okay. So the answer is mixed basically. We live in an economy, we live in a country. In every country we have some economy, and I'm not a good person to talk about these things. I'm an astronomy person. I can help you out through these things. So today I chose this topic to like rethink yourself. Guys, rethink yourself that you are creating some light pollution that not only affects the astrophotography as well as the human people, as well as the not human, I was talking about the animals and birds as well. So another question that is that's from also Masum Jetwa. Dark sky functions as a non-excludable, non-rival public good. Okay, you are explaining these things. Questioning is more is the
Ma'am, what we can do is we can make people raise their hands and they can
yeah,
ask you
that's
directly.
better. That's better. I
Yeah.
would like to say.
Yes. People may raise their hand. Manishka, you can go ahead.
Manishka, please go ahead. Okay.
Wait a second, wait a second. You won't be able to turn on your mic.
You
Wait a
can
second.
try
Now you'll be
again.
able to. Please continue.
Hi, ma'am. My question was, how can regular people practice on environmental stewardship in daily life?
Okay, it's not about turning off all the lights you can see on the street, turn off the lights, turn off the lights. It's not about this. But at the same time, you need to be aware of this particular thing, that how much you can contribute yourself, to the climate and the astronomy as well. I used to capture a lot of pictures of the sky. But when I am in a dark sky place, for example, I'm in Kosani or like in a highland places, that means on hills and mountains. So I click a lot of pictures, and the Milky Way band is so beautiful. But at the same time, I live in Chandigarh, and here the light pollution is so much. I barely see Orion. Orion barely see. That's very hard. So you can turn off the extra lights that you could see around you, that's in your house, in the also there is also like, let me give you some examples. Okay. I have this with myself. Okay. 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 For example, this is a street light bulb, right? Okay, some people used to apply this, and in this particular orientation, some of the light scatters in the upper direction and some of the light scattered in the lower direction. If you just turn this out, so you could see all the light will fall into one place in a like particular region. The light will not going to scatter in the upward direction, that is in the sky. And that's how you can regulate this like stewardship to help the astronomy. Okay.
Thank you,
Thank you,
Minister.
Okay.
We will have Masoom sir's question now. Masoom sir, you can go ahead.
Mausam sir, please
Hello.
turn on your camera as well. Please turn on your
Hello,
camera and please go
am I audible?
You are
Yes.
on. Yeah.
Yeah, so a lot of times I have seen that whenever there is a debate between economics and environment issues, the plain, slides or the focus slides towards, uplifting people through economic activities,
Hmm.
and some part of that is always suffered by the environment. And recently in
Absolutely.
Gujarat, if you
Correct.
have heard that they are now cutting down the Aravalis, I was
Hmm.
not sure whether it should be done or not. But the thing is that the policymakers should bring these things to the people, and we as a part of the community should talk about it. And what they need is some solid evidence. So my question to you is that when we talk about environment, and like it's not a single point problem. We have like multi-agenda things, astronomy is being one of the part that we do. How as a you know how as a framework it works when we select between economic development of people who are
Hmm.
not getting basic things versus the people who are already uplifted or privileged and polluting more compared to the people who are yet to receive the basic amenities. So, how does, as an environmentalist, you figure it out that astronomy is a tool which can, be a bridge between both of them? So, that is my question to you. Thank you.
Okay. Let me take you this particular thing. First of all, I have mentioned a comment in the chat box that you can ask your questions about astronomy as well, because I am expert in that, not in economics. First of all, but if we talk about my views, okay. So when we talk about dark sky reserves in India, we are having if you have read this year's budget, we have some budget particularly for astronomy and astrophysics. In perspective of the dark sky reservation in Ladakh and Leh, we have um, observatories, and also this is a prominent place of the dark sky reserves, as well as in starscapes as well. We are also advocating the dark sky reserves, right? So economy is all about how people invest in money and how the government will going to like just pass it on. But I feel I am an astronomy person and not from economics background. So I'd like to take this in a personal way. Uh, you can DM me whenever you want to have this conversation with me. Okay, I'm good at debate, but at the same time, but this is not a good platform. Okay, Another question that we have is from Tanvi. Okay, so she's asking about some citizen science projects. Okay. So you have heard about Zooniverse. This is the biggest citizen science platform. I not biggest. I'm not like quoting this, but at the same time, I'm saying you would like to work on different projects of astronomy as well. I use Zooniverse like for playing purpose as well sometimes, because even there are a lot of um, projects that are going on in the field of astronomy where you can learn, where you can use it as a game. At the same time, you are discovering something. You are helping the scientists who are there working on the data, and you are helping them out to classify these things. So you can have that, as well as international asteroid search collaboration, with Propagation Institute, that's that is organizing this particular event. At the same time, we in Sovanacharya citizen science program, we run these things, that is asteroid search collaboration. And you have seen my you could say, sir has told about me that I have discovered so many asteroids and preliminary and provisional discoveries. They all are from this particular citizen science projects. Yeah. Another is from Lakshmi, not being able to. Okay. Which fields are best to write a research paper on physics and biology, botany specifically in one itself? Okay. So both are the subjects that's important as a part of the science. Okay, it totally depends on which field you are going to work in. If you are going to work in physics, okay, we have a lot of things. If you work on biology, especially botany, you can work with that. But in between of that, we have a particular field that is known as astrobiology, where you use biology in the terms of astronomy. That's the connection if you want to have this. Okay, but I think in India we have limited resources. Okay.
Let's take Advik's question, ma'am. We have got a question.
Yeah. Okay, please go ahead. Whoever wants to have a question.
Yeah, so I just want to ask that I was working on one theory on dark matter, just like
You're working on theory of dark matter?
Yes, I'm working on a lot of stuff.
Interesting, bro. Interesting. You know, you are very
So I
smart.
just want to ask if you would want to work with me. Just
Okay.
ask me that.
Okay, dark matter. That's a very interesting subject to learn. Even I am also learning on dark matter in a higher terms right now. So if you want to collab with me, I am happy to have you with me.
Yeah.
Have some
Okay.
discussions. Okay.
Yeah. Okay. Sure.
Okay. Anyone wants to have something?
That's all. That's all. Okay.
Okay. What's
That's
your
all
age, by the way?
I'm gonna turn 13 this year.
Oh, 13. That's great. You're in 10th standard, right? Yeah.
I'm going to be in 8th.
I'm going to be in 8th standard.
Yes.
That's great. Impressive.
Yeah.
Okay. Next is, how are photographs of black holes taken, ma'am, since they do not emit light? Okay, that's a great question. Black holes are something which does not radiate light. At the same time, if the light is entering into this black hole, they're not going to emit that particular light. But the image are taken. We have some, you could say, methods to click these images. I think, sir, Jitu sir, I think we should organize a particular session on how these methods are to click the photographs of black holes. Because that deserve a totally complete session. Okay.
By the way, we were having on that as well, ma'am, but not in this series. Previously, it's on the Propagation Institute or YouTube channel, everyone. You can just get from there as well. And the people who are interested in citizen science are whatever the projects if you want to do. Okay, there is a complete 2 days of workshop, which is also available on our YouTube channel. You can just check out. Okay, you'll be able to get to know lots of platforms like the Juniverse and Globe at Night, and lots of platforms are there.
Okay, but if the people want, we can have one session again. Yeah?
No, we'll definitely do that. Whenever you have the time, we'll definitely do.
I would be more happy to have a session with you.
Okay.
Okay. I have dropped my Instagram handle in the chat box. So if you want to have some conversations regarding this, okay, these particular things in astronomy, astrophysics, wherever you want some guidance, you can just DM me. I'm very happy to have your questions. Okay. Any other question you want to ask? From any particular field, not about biology, not about light pollution, but anything, So you can just unmute yourself, raise your hand, or write in the chat box.
Also, people are asking about slides. Okay, don't worry, I'll get everything. Don't worry.
Ah. I'll share the slides, Don't worry for that. Okay, anyone wants to have? Okay, Lakshmi Atwani, she has asked a question. Okay, astrobiology for the very vast topic. Yeah, I would like to say that it's a very vast topic. Because when we talk about astrobiology, it covers most of the things. Okay, let me give you one example of International Space Station. Right, in International Space Station, we are having astronauts. They are working on the astrobiology as well, because they are conducting some experiments of how the life will be there, beyond the Earth. So they are having some experiments, and that's on biology. Like if you want to colonize Mars, or be there on the Mars, you need to understand the concepts, right? If there is possible of habitability or not, is it habitable or not? Okay. Who has raised his hand? I can see a raised hand.
Yeah.
Okay, please
Also,
unmute yourself.
please turn on your camera and you can ask.
Yeah, a question that I ask every speaker, that if you can recommend few books or some lecture series which kids can go through, that would be very helpful, so that they can,
Okay.
get inspired to work on astronomy or something like that. Few books.
Okay.
I want at least two books which are very basic and, interesting for kids to read. So they always come to us and ask that, sir, which books can we read, or can we get it from Amazon or something? So I would request you to please tell us two
Okay.
or three books
Let
which
me answer
could
this.
personalize. Yeah,
Yeah,
sure. Thank you.
thank you. Let me answer this with my experience. Okay, first. Okay, from my experience, I started looking the things from encyclopedia. There is a book called Science Encyclopedia. From a very small kid, he or she can have that, because in that science encyclopedia, he's not just looking into astronomy, but at the same time, he is getting an idea of what exactly the science is. There are a lot of field that connects from one to another. That's where the small kids can start from, not from the books of astrophysics and a lot of things, but from a basic encyclopedia. That's very helpful, basically, because it is having some facts, it is having beautiful images. Those beautiful images are very captivating for eyes. One can start from that, and later on he or she can have some YouTube lectures. I would like to recommend that, YouTube lecture that is having or documentaries that is having beautiful visuals. Because if a kid is watching something or learning something, he or she can get a better grasp by looking at images, not by learning a lot of paragraphs or reading something. Everybody would get bored from that. Okay, we have a question from Dhanvin. Okay, mentoring in CERN blast competition. Okay, first of all, I don't know what exactly it is, but I would like to mentor you in this particular competition. You can text me there in the what here? Okay, in the Instagram handle I've shared. I will share some handle again. Okay, can
Ma'am,
you
there
suggest
is a
some
more
books to
questions.
read? Yeah, I'm reading this particular comment.
There is a question by Lakshmi Atwani, ma'am. I'm pasting in the chat.
Yes,
Please
please.
go to it, ma'am.
Okay, actually, my botany teacher asked me to collab with them for research paper. Okay, great. You can contribute in both physics and botany, because these both are science fields. Okay, You can have that, you can work on any research paper if you want to uh, be in research, that's a very great thing. Okay, I don't have Instagram. Okay, I will give you my email. That's Kushi 3000 Stark. That's my current email ID, which I'm using. I am typing in the chat box. Here you can mail me, and that's a great thing. Why do you like astronomy? Okay, so this is a question I heard a lot of times, not once, but every time I am in speaker or I'm talking with someone. I'm a science communicator who is communicating science, most prominently astronomy. But what makes me feel like why do I like it is the stars. First of all, I look in the night sky. I see a lot of the stars. Every time I look at the night sky, every time I can just, okay, this is particular constellation, this is particular constellation, I giggle myself. That makes the thing very fascinating because human have evolved by looking at the stars. This is the first thing. Okay, any questions you wanna have is you can have in the discussion group. That is that's link is provided in the chat box as well, so you can have that conversation with me as well as with our panel members. Yeah, they all are like experts in the field.
I think
By
the
the way,
questions are now.
people who are joining the discussion group, let me just tell you a few things. Few instructions are there. You all have to introduce yourself first to the other members as well. Okay, then only you'd be able to have the conversation because it will be way more easier after that. So after joining it, please introduce yourself first.
Yeah, and for today's session, I think the questions are now saturated. They are almost done. Ma'am has answered a lot of questions, very important ones too. And we have reached almost 2 hours. So this has been a long session, but a lot of people say it's so incredible.
Okay, I have one more thing to say to the Masoom sir. Masoom sir, if you are here still, you are asking about a book. Let me just suggest you a book if there is any kid. Okay, yeah. There is a book called How Space Work.
Yeah,
Encyclopedia. Okay, maybe
yeah, that's also an encyclopedia.
okay. This one is the best book ever for any kid. Okay, this one, How Space Work. And if there is any school student, it's really a nice book. So yeah, you can just go through it.
I think Sovan sir has another question that says, "How did you fall in love with astronomy and how in life?"
Okay, that's a great question. Okay, so the story is not starting from like many people say. When I was a kid, I was looking at the stars. I was fascinated. So in my case, it was not like this. Okay, I start getting into astronomy when I was like 16 years old. That was the thing. Uh, 15, I guess. Yeah, 15 or 16 years old. I have attended exhibition of ISRO, where I met a scientist. I explored this particular field of the science. Okay, there are a lot of science field backgrounds. There are a lot of rockets, satellites. I have interacted at that place with the most of the scientists from ISRO as well as PARC, also from a lot of, you could say, institutes from India. Okay, at the same time I fall in love. Okay, I will going to have this with me. So at that time I started exploring myself from encyclopedia as well. I was talking about encyclopedia, and that was the point. It was a time I was looking into encyclopedia. I was like, okay, that's great, that's a great field. And here I started my journey. I bought my telescope. I was in connection with a lot of people, one, two, three, like this steps, and then having conversations with them. Okay, how to capture the photographs of the constellations and sky. And there I am pursuing this as a career, pursuing this as a hobby, doing this as an astronomy educator at Starscapes. And that's how the things evolve. It is like, it's not like you can just stand here and climb on the top of the ladder. It's not like this. You have to take the steps. That's the perfect manner of going into a particular field. I would like to say that. So if you are a kid, if you are a high school student, if you are a bachelor student, or if you're a master student, okay, go step by step. That's the best way to get into the field. Learn, read a lot of books. This is my suggestion. Read a lot of books. Do some research. Everything is available online right now. We are having our page. A lot of speakers were there. Previous discussions were there. If you're free, if you have some time, instead of scrolling Instagram or YouTube reels, you can go to our channel, that's Propagation Institute channel, and here you could see a lot of speakers have told about astronomy, a lot of things in a different way. So you can explore that.
Okay, ma'am. It's really nice to have you here, ma'am.
Thank you so much.
It's an honor to have you here, by the way. It was really amazing. Till now, whatever the speakers has been come here in the series, everyone was so amazing. And the next week we are having the Astha ma'am, which is already going to be so amazing. So everyone will end this session here only. Everyone, please just turn on the camera. And what we actually do, ma'am, like we just capture the moment. So
Oh, great.
yeah, everyone, please turn on the camera so we could just.
I'm a
capture this
photoholic
moment.
person.
Yeah, and we are having Sohan sir. Thank you so much, Sohan sir, for coming here. And yeah, everyone, please turn on the camera.